Okay guys, so I was writing earlier, right, in mirror equation. So it turns out that there is this relationship between the focal length, object distance and image distance, and given by this equation 1 over f equal to 1 over s plus 1 over s dash, where s is object distance, s dash is the image distance, f is the focal distance or focal length, okay, of the mirror. So let's do one example using this information. So I'm going to read this, I'm going to erase this also. Let's see. So example, a 3 centimeter high object is placed 20 centimeter from a convex mirror with a focal length of magnitude 8 centimeter. Okay, so let's write the given information. A 3 centimeter high object. So the height of the object is 3 centimeter. It is placed 20 centimeter from a convex mirror. Right. So the distance, object distance is 20 centimeter with a focal length of magnitude 8 centimeter. F equal to 8 centimeter. Okay. Determine the position of the image and the magnification. It is asking us what is S dash, position of the image, and there is also a quantity called magnification, M equal to what? I did not mention earlier there, so let me mention here real quick. So when we are talking about the thin mirror equation, there is also something called, we can define magnification. Okay, magnification of image basically. What it is trying to say, this quantity does is it will give you an idea of how big or small is the image font with respect to the original object. Okay, so MAGNIFICATION, magnification represented by lowercase m is given as minus s dash by s. Okay. This negative, so s dash is what? Object distance, right? Divided by s is image distance. You will also see this quantity is also actually related to m equal to h dash by h, where the height of the image divided by height of the object. But for now, we don't need this part. We just need this part. Okay, so I'm going to erase this one. So negative sign will tell us, basically we use the negative sign whether, if we get to see whether our object is diminished. If the object is not diminished, if it's enlarged, then we won't use the negative sign, okay, because then it won't make sense. So negative sign is there to say if the object is diminished. Okay, alright, so magnification is given by this quantity. So if you remember, we don't need to actually draw a diagram, ray diagram, I mean we can draw. So this is a convex mirror, right? So it's kind of like this, and then it has the focal center somewhere around, let's say, if we have optical axis, it has a focal center F, right? Let's say this is like the center. And then the object S is somewhere at 20 centimeter, right? So there is object here, this distance, let's call this is S, distance 20 centimeter, and then the image is formed here somewhere. But we are just asked only the object distance here, okay? image distance S dash. So where does the image form? Even without doing a diagram, we should be able to just calculate it numerically, okay, in this one. So let's see how we can do. So we know we can use a thin mirror equation, right? So using thin mirror equation, we can write what? 1 over F equal to 1 over S plus 1 over S dash. We are given pretty much everything here, right? We are given this quantity F, we are given object distance. Yes, so we should be able to find this one unknown quantity, right? So let's do it here. So 1 over S dash, I'm just rewriting that equation, 1 over F minus 1 over S, right? So now I'll just plug in all the information. So what is, well, actually you can just do one more step. 1 over S dash equal to what? This is Fs, this goes here, S minus F, right? If we are just taking a LCM here. And then if we invert this, then it becomes what? S dash equal to F times S divided by S minus F, okay? So every time, you can really use this equation if you know just two of the quantity directly, okay? So this becomes like a formula. So substitute the values, and then with substitution of value we get what? F is what was the value of F? It was 8 centimeter, right? 8 centimeter times what was the object distance? It was 20, right? And then what was this S is again 20 minus what is the focal length? Again 8, right? So what do you get here? If you punch it in your calculator. So you get this about 0. Oh, we wanted to, 0.66. No, that's not true. That's not true. 160 divided by 12 won't come at 0.66. In my notebook I have, okay, 13.3 centimeter. Okay, so this is the object distance. Okay. So now what kind of image is formed? Even without drawing a geometry, we should be able to tell what kind of image would be formed. So now, to see whether this image formed is whether larger than the object or is it smaller, we are going to calculate the magnification. So using this magnification equation, using formula really, rather than equation, we can find m equal to what? S dash negative of S dash by S. Let us see. Our S dash is what? We just got that was 13.3, right? Is that the, wait, just a moment, let me see. 13.3? Okay, yes, 13.3. 13.3 divided by what is the object distance? It was 20, right? So if we do this, what do you guys get? You guys get like minus 0.665, which turns out to be close to minus 0.7, right? So this is the magnification. This is a dimensionless quantity because it's just the ratio of the distances. So it tells us that the image formed is diminished, right? So diminished image. Diminished or minified, right? And we also have this negative sign here, okay? So, alright guys, so the image formed is the diminished image, okay? So that's it. We found the magnification, we found the image distance. Okay, so right, we can also do draw how to locate the image. We can draw a ray diagram, but the easier way to do is really you can just calculate this distances using this formula and then locate the image. Okay, that's also possible, and you can also see whether the image is diminished or magnified. Just a moment. Okay, so let's look at other cases. Okay guys, so far we talked about the reflection of light when the light touches some surface, right? Now we are going to look at another property of light. This is a refraction. So refraction. Refraction meaning when the light travels in one medium, it touches interface, and then instead of reflecting back, it passed through the medium, meaning we do need some sort of transparent medium, right? We cannot have completely opaque like a mirror. We cannot have that for refraction. So when does refraction takes place is basically when we have a transparent medium or semi-transparent medium. So let's say we have a aquarium glass, here is an aquarium full of water, and then the light enters from here, and then there is this water here. So the light has to travel, right? Now there is a change, it reaches to the interface, that's the boundary between the just air and the water. And once it gets there, what happens is part of the light reflects back, some part, but some of the light will enter through the water, okay? So that light, when it enters through the light, something happens. The light bends, actually, when it enters from one medium to the another medium. And that bending of the light is called refraction, okay? So refraction basically like this. We have the, let's call this is a medium with refractive index n1. Let's call this is a medium with refractive index n2, and this is I'm drawing this dot dot dot. This is called normal. Normal means basically you're putting a perpendicular. Like for example, what is normal to this would be if we put dot, make a dot 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 line here. This would be normal, and if you want to take a picture of this or draw it on the board, it would look like that. Okay, so normal. Okay. So now, when the light is incident here, light ray, when it touches this boundary, some of the light is going to, it's going to enter, because let's say this is a transparent media, right? Let's say maybe water. This guy here, let's say this is the air medium. Okay, what happens is it bends. When it bends in with it bends and it becomes something like this. It gets closer to this normal line, okay, if it is a water. If it is something else would happen. Okay, so this bending of light is called refraction, where the light bends but now there is also change of the direction. Okay, this is a refraction. So we have this scientist here, Wilbur Snellius. He was a Dutch astronomer. He gave contribution to law of refraction. Law of refraction is basically empirical description. Okay, so let's look at few things here. Okay guys, so earlier we talked about the mirror. Okay, so mirror are a polished, so they have a polished surface, right? Now we are going to talk about the thin lenses. Okay, so lenses are transparent, okay, are semi-transparent. Alright, so it's unlike the mirror where the surface is polished, lenses are transparent. Some of the, I have some of the, lenses here. I'll show you guys in a few minutes, but let's see. So earliest lenses were made from polished crystals, typically quartz. There was, something called Nimrod lens. This was found in Assyrian palace of Nimrod, possibly used as a magnifying glass or burning glass to start a fire. Ancient Romans and Greek, they filled the glass sphere with water to make a lens. Okay, lenses. That was around like 50 AD. So you see one diagram here. Alright, now since I mentioned about the lens, there are also images formed by lenses. So now we'll go back to the ray diagrams. So images formed by lenses. So basically we'll look at two types of lenses. So basically two types. One is called converging and another is called diverging. Okay, diverging lens. Just from a name it kind of seems obvious, right? Converging means it has to converge the light. Converge means bringing all the light, try to bring it together, right? So converge. And diverge means it has to try to diverge the light, take it away from each other basically. Okay, so it turns out this is a type of converging lens here. Do you guys see? This is here. Okay, it looks kind of like this thing, right? So this is a converging lens. It's also, so now if I have to draw this on the board, it is going to be like this. Here it's, so converging lens, so we draw it like this. Okay, diverging lens, it looks like this. You see, earlier if you had to, so it has this like a cave. It's like a diverging lens, right? So it is, if I were to draw this here, it's gonna look like this, right? So I can really draw. So how do you know which is which? The one that is thicker, right? Thicker in the middle, this is a converging. The one that is thinner in the middle, this is a diverging lens. Okay. So really, when you go to the you go to for your eye checkup, you get glasses, you get combination of these lenses basically for your eyes, right? Okay, but then about that we'll learn in another class.